to solve another Leetcode problem. 2435 paths in matrix whose sum is divisible by k. So this problem is similar to Leetcode problem 174. So this is for dungeon game. So as you can see, we are given a grid and we want to attack from the top left corner to the bottom right corner. And for our problem, it's the same. We are also going to attack from the top left to the bottom right. Yeah, but for our problem, maybe we don't need to use the binary search. We can directly use DFS plus memorization to solve it. So the problem is that for each of the position, we have to attack the sum of them from all other different places. So for example, if we are at this position, we need to have a record of all different combinations, the sum of them. Maybe we're going to have a value of 5 plus 2 plus 0, it is 7. Maybe from here we can go like 5, 3, it is 8. It can have two different values. But for another cell, it may have more different cases. Yeah. So for example, we may have like 7 plus 5, we may have 12, or we may have 8 plus 5, 13, or we may have 9, or we may have 5 plus 2 plus 0 plus 5, it may another 12. Yeah, but here we've already counted, so it may have more different combinations. But if this grid is really big, so the combinations are gonna be cubic. So yeah, if we solve it, actually this is yeah, it's not a matrix actually, it is a cubic. We needed to prepare three-dimensional DP to solve it. Yeah, but by using DFS we can solve it easily. Yeah, because by using a cube we have to prepare another vector, like yeah, we need to prepare 3 vectors. Normally while preparing 3 vectors it's gonna be a little bit difficult. If we are familiar with DFS, I think we can learn from DFS first, and then we can try to convert the DFS to the tabulation. So for the DFS, actually we can just start from the top left corner in this position, and we're gonna start search. And for each of the position, actually we're gonna record all the combinations of the different cases. But how can we record that? We can use a DFS. We can just start from the R and C. So this is from the beginning. And we also need another variable. So I'm gonna call a T. So this T is the total sum. So at each of the position, for example, at this position, we're gonna R and C is fixed, but the total sum may be different. And how many different cases of the total sum? So it is given by yes, it is given by this k value. So this means why it is a 3D problem, 3D dynamic programming. Because we are given this k, so it means the time complexity would be r times c times this t. So this t is equal to k. So this is gonna be the time complexity. Why? Even this k, even this total value, maybe I'm not sure. Maybe this total value can become bigger and bigger. It may be like 10 to the power of 5 or 10 to the power of 9. So if it is like that, r times c times this number, definitely it's gonna be time limit exceeded. But actually we don't need to keep so large number. We can just use a k. K is less than or equal to 50. Yeah, because for a number like because for a number from 2 different cases, so for example at this position, maybe this number is 10 to the power of 9, it's a big number. We are going to check if it is divisible by 50 maybe. Yeah, so we don't need to keep so large number. We can just divide it by 50 first. For example, if it divided by 50 is 0, so we just use 0 plus this number may be 5, so 0 plus 5, or maybe 0 plus 50, and then 50 divisible by 50. It means that this is true. Yeah, maybe at this position it's also the same case. So definitely we don't need to keep this R and C, just R and C is small, but for this total, we don't need to keep so large value. We just need to make it from 0 to 50. We don't need to keep a so large value. If we can solve it like this, definitely we can solve it. Yeah, so let's just check the values. So the R times C, so m times n is 5 times 10 to the power of 4, and k is 50. So this means the time complexity is 5 times this number times this number. It is 2.5 times 10 to the power of 7. So this means we have to solve it like this, otherwise we cannot solve it. Normally it is going to be time limit exceeded. We have to control this value of k. Now let's try to write the code. As the final result going to be use a mod, we're going to prepare a mod plus this 7, and I also needed to prepare this R and C. It's going to be length of the grid and the length of the grid 0. Now we can prepare a class with DFS. So inside the DFS, it's going to be RC and total. Now I'm gonna define this function. I'm gonna write a path first. So the final return gonna be the DFS from 0 to 0 to 0. So the total from the beginning is 0. Yeah. So I'm gonna set it from the 0, and then I'm gonna increase it one by one, while I'm go to the right side or go to the bottom side. Now I'm gonna have a boundary tag. So it's gonna be exactly like the same code here. So this is for the dungeon game. It's gonna be exactly the same. Let me just copy it and change a little bit to make it work. Yeah. So if this R goes out of boundary or C goes out of a boundary, I'm gonna return a false. Yeah. Now I'm gonna have this total. So this total gonna be, yeah, let me delete these areas. So this total gonna be updated to so gonna be updated to total plus the grid R and C, and this value. Yeah, so the total would be updated to this value modular k, and this is really important because we used the total for class, and this total must be controlled less than or equal to 50, otherwise you cannot solve it. So this is the most important point. Except that we just need to check the final return. It must be 10 to the power of 9 plus 7. Yeah. Now we're gonna have this kind of tag, the return tag. If we go to the bottom right corner, and we're gonna check this. If it is go to the bottom right, we're gonna return true if this total. So here we can change it to modular k equal to 0. But we cannot return true or false. We're gonna count it. We're gonna return 1 and 0. Here gonna be the same. We're gonna return a 0. Yeah. So from here, we just need to check all combinations. So from here, I'm gonna return a result. So result would be those two combinations. So this means I can go to the bottom side, or I can go to the right side, and I can have a final return. So result would modular a mod. Yeah. So this is going to be the final code. Now let me just run it to check. Yeah, it seems it's not okay. Yeah, normally I should write it myself. If I copy the code, it may make mistakes. Yeah, so this means if I go out of the boundary, I'm gonna return a 0. Otherwise, so the total yeah, the total should plus equal to, yeah, so for example, if I have this total value, let me make it without here. So the total should plus equal to this grade R and C, and a total equal to 0. I'm gonna return a 1, otherwise 0, and then I'm gonna combine different cases. Yeah, this is not all. This should be use a plus. Yeah, normally I should not copy the code. And here, let's just check it from here. If we do not modular the total, let's check what's gonna happen. I think it's gonna be time limit exceeded, because if this total is too big, the R times C times total gonna be the final time complexity. It's gonna be really a big number. Yeah, let's just have a check. Yeah, as you can see, it cannot pass because of the memory exceeded. Normally for memory, it is also for the time, but we can optimize from the time first. So for here, this total number is too big, so we need to make it smaller. But how can we make it smaller? Yeah, so we're gonna set a total to total plus this number, a modular k. So if we modular k, normally the time complexity should be okay, R times C times 50. Yeah. Now let's just have a check if it works. Yeah. Now let me submit it to check if it can improve a little bit. Yeah, as you can see, it improved, but the problem still is the memory exceeded. If the memory is exceeded, because normally for the Python, if we use 3-dimensionals like 3 vectors RC and total, it will gonna be time limit exceeded because this number is too big. It is 2.5 times 10 to the power 7. I mean this number times 50. It's gonna be a really big number. Normally we can fix it easily by using the library from the Cascade. So we're gonna prepare the result. Yeah, first of all, we're gonna store the DFS inside the result, and then we're gonna, for each of the function call, we're gonna clear the cache. So DFS dot cache clear. Yeah, if we clear the cache, normally we can solve the memory limited problem. Yeah, and finally we're gonna return this DFS. So this means first of all we're gonna record a result inside the result, and then we're gonna clear the cache immediately, and then we're gonna get the result. Yeah. So for the next function call, normally, normally we prepared a new cache just to clear it. So in this way, it means we're gonna use the memory in a loop, not the total memory, and this is a good idea to clear the cache. Now let me submit it to check if it can pass. Yeah, as we cleared the cache, so we can pass it. Although it is 3 seconds, because for Python, while we are doing the 3 dimensions or 4 dimensions, it's gonna be really slow. But anyway, it works, and this is easy to understand. Thank you for watching. See you next time.